This devlog will show whether or not I can make the core mechanics of my game work. It is a little terrifying, to be entirely honest with you. If I can't make this work, the game's dead. One of the implicit main goals of the game is to build a hoverbike. Building the thing is nice and well, of course, but it would be pointless if you couldn't ride it afterwards. And so, we set out today to create a hoverbike that's fun to ride. Every function of the hoverbike should be tied to a specific component. That way the state of its completeness isn't binary when you build it. Got the hover thingies on but no forward thruster? Well, you can float but not go. Hover unit brakes during a flight? You'll have to bring the bike to a stop without plowing into the ground. Furthermore, different parts that can be installed in the same spot can have different statistics and change the feel of flying in the bike. For this part of the development, I'll be focusing on the outward-facing parts, i.e. the parts that actually do things and aren't just there to support other parts. If you want to look at it like a car, we'll focus on the wheels now, ignoring all the bits that would actually make the wheels spin. We'll take care of those later. Let's start with the hover figures, repulsors, which was also my nickname in high school, fun fact. These are conceptually pretty simple. They're a rigid body attached to the main vehicle via fixed joints, and they continuously measure the distance between them and the ground. They then apply a force to themselves upwards that is inversely based on the distance. Essentially, the closer a repulsor is to the ground, or any object for the matter, the harder it pushes itself up. The formula it uses for this is exponential instead of linear, which allows them to settle into a specific ride height much nicer. I also put a main thruster on the bike. This one is fairly simple. If a player sits on the bike and presses the go button, the thruster applies a force to itself. Not exactly rocket science. Lastly, for this first design iteration, I added a back fin that would be responsible for yawing the bike. At first, I tried to make it actually physically accurate, in that it would apply a force to itself based on the angle of the fin and the speed of the bike. The problem with this was that the force would roll the bike on its side. Instead of spending hours trying to fine-tune the force to angle to speed ratios and the position at which the force is applied and all of that, I just cheated a little bit. And instead of applying the force to the fin, I applied torque to the bike itself. So, the first iteration of the bike is done, and after some testing, there is one major problem. It really likes to do backflips. Now, a little bit of rebellious spirit in the vehicle is good, actually. After all, you're meant to feel like you're strapped to what is essentially a jet engine, albeit not a terribly powerful one in the great scale of things. But this is too much. So, why does it flip? In order to understand this, we first need to understand two basic principles of propelling a physical object: center of mass and center of thrust. The center of mass is the center point between all partial masses of a body, or collection of bodies in this case. Take a pen and balance it on your finger. The center of mass of the pen is above the point of contact between your finger and the pen, probably towards the center of the pen. Center of thrust is where the force we're applying to the body in order to propel it is. Now, in real life, the center of thrust is a bit of a complicated affair, as most processes that produce thrust are not perfect and subject to phenomena that disturb them. In video games, we don't have that problem. We can apply a force to a point and it will do it just perfectly. Now, if the center of thrust and the center of mass line up, we can push a body straight. However, if the two are not aligned, part of our thrust will rotate the body instead. This is what's happening to our bike. Earlier, I manually set the center of mass of the bike a little higher, And so the thrust from the thruster wants to spin the bike upwards. Now, we could just lower the center of mass and bring it in line, but we actually want the two to be a little off center. If this were a plane or a rocket, we'd want them perfectly aligned. But it's a hoverbike, and as such it needs to fulfill a certain fantasy. And part of that fantasy is that it steers a little bit like a conventional bike, through leaning. In conventional bikes, leaning means that the center of mass is shifted to the side, meaning it's misaligned from the center of thrust, which is where the wheels connect to the road. And the bike is rotated to the side. If we want to emulate that in a hoverbike, our center of thrust also needs to be lower than our center of mass. But there's a solution. A front wing. This wing will apply a downforce, depending on the speed of the bike, and cancel out the tendency to flip backwards. I was expecting to have to spend quite a lot of time fine-tuning the amount of force applied here, but it just kind of worked. That's neat. At this point, I also took the hoverbike to the village for the first time, and the results weren't great. Icarus flew a little too close to the ground, and his wings glitched out and shot him miles into the sky, I guess. This bug would haunt me for a while. At first I thought that I could prevent this from happening by simply clamping the upwards thrust of the hover thingies. By the nature of the formula I had chosen for them, as they approached a distance of 0, the thrust would approach infinity. At the time of implementing this maximum, I did not consider that the repulsors have collision, and as such would never actually get to a distance where this could become a problem, and as such this fix did nothing. At this point, I adjusted the game speed down and tried to replicate the bug, hoping to see if there was any visual indication of what the issue might be. And yeah, there was. There sure was. Sometimes, the front repulsors would kind of collapse into each other, cross into each other's raycasts that measure the distance for the thrust calculation, and then feedback loop each other into producing stupid amounts of upwards thrust. But why did this happen? Was it a fixed joint component not working as intended under certain circumstances? My first instinct now was to go to the project settings in Unity and raise the physics iterations, basically making Unity's physics engine work harder at the cost of higher CPU load. That didn't solve the problem either. So I started Googling and actually came across a page in the Unity manual that addresses this specific problem. And so I worked my way through their recommendations. I upped the physics iterations again, this time to their recommended values, which are pretty significantly higher than the defaults. Nope. And then I increased the mass of the repulsors, and that actually did it. Apparently, a big difference in mass between rigid bodies connected by joints would lead to jank. A single order of magnitude was apparently fine, whereas 2 orders of magnitudes are too much. So I raised the mass of the floaties and lowered that of the bike. And yeah, it worked. At this point, I also moved all my physics-related code from fixed update to update and scaled it properly to the frame rate. This has 2 effects. The positive effect is that the vehicle physics become a little bit snappier, as the forces applied to the rigid bodies are calculated more frequently. So, while the actual physics still run at discrete intervals, the numbers I feed into the simulation should be more accurate. The downside to this is that if the frame rate ever tanks, or even just spikes, things can get a little janky. I'll have to see if I keep it this way or change it back. As you can see in the footage, the rigid bodies kind of jank around all the time. This is a visual thing, it doesn't actually affect the physics at all, and we can just hide it when we do the actual model bike. Next, I tuned some of the values a little. I reduced the overall drag of the bike to make it a little floatier and driftier, and adjusted some of the thrust values. At this point I spent an entire in-game day, which at this point is about 5 minutes, just driving around. It's actually fun. I then implemented rolling. We already discussed how this works earlier, and implementing it was as easy as just applying torque to the bike. This is also the only function that is not directly tied to a part. Apart from the seat, I guess, because it would be executed by the driver shifting their body weight around instead of using the mechanical part, and in order to have a driver you need a seat. At this point, I had a problem though. Rolling was not as effective as using the yaw fin, which was on purpose, but there was also no downside to using the fin. So I added a little bit of logic to the fin that it would increase the drag of the fin quite a bit when using it to steer. So now you have the choice of either rolling, which is less effective but maintains more speed, or using the fin and losing speed at the benefit of having more control. Choices. Lastly, I implemented aero brakes. These are just wings that fold out when you brake, massively increasing their drag, slowing the bike down. With these in place, I lowered the overall drag of all components even more. However, this is only half the battle. I will now have to create an actual model for the bike, apply the construction system to it, and also implement other stuff that will make driving the bike feel good. Dust that kicks up, sound, all that jazz. Once that is done, a build goes out to the testers so they can help me nail things down to where it really feels good to drive. As well as making me aware of the inevitable bugs. If you want to help me test the game, check the description down below for the link to my Discord server. If you liked this video, please consider subscribing. We're nearing 150 subs, which would be a nice milestone. And beyond that, I will see you around. Have a good one.